We're continuing a problem we started in a previous video. We are going to solve this linear programming problem using the simplex method. In a previous video, we set up the initial simplex tableau. So we verified this was a standard maximization problem, and we took the objective function and put it at the bottom. We did some shuffling, moved all the letters to the same side. And then our constraints, we changed from inequalities to equalities by introducing slack variables. And then we had to have these inequalities here, where each variable was non-negative. They don't go in the Tableau, but we must have them to do the problem. So now that we've set up the initial simplex Tableau, we're going to start the simplex method process. We always determine whether an optimal solution has been reached. Well, we know it hasn't because we just started, but let's go through the process anyway. We know we have an optimal solution if there's no more negatives down here. So if you have negatives in this little area below this line and to the left of this vertical line, you know you're not done. So we're going to actually have to do this process. We're going to have to pivot. So how do we find our pivot element? Well, we are going to locate our pivot element. First thing we're going to do is look for the pivot column. We're going to choose the most negative entry in the last row to the left of the vertical line, right here. Most negative. And when we say most negative, I want you to think about which one, if you drew a number line, would be the furthest to the left. So this is the most negative entry. So that means this whole Z column is our pivot column. Okay, so I'm not going to circle it because it made it kind of busy, but this is our pivot column. Maybe I'll highlight it. I think I'll highlight it for you. So there's our pivot column. Okay. Now pivot row, it says divide each entry in the pivot column into the corresponding entry in the constants column. The pivot row is the smallest non-negative ratio. Can never divide by 0. So be real careful with this word divide into. I want you to think about doing constant entry divided by the pivot column entry. So let's make some ratios. So we are going to take the constant entry and divide by the entry in the pivot column. Okay, so we'll do 23 divided by -3. But we have to be careful because it says we want the smallest non-negative ratio. We cannot have negatives. Can't have that one. Then we do 10 divided by -3. Again, the 10 from here, the -3 from here. That's still negative. Throw that one out. So then we have 30 divided by 11. And you don't have to simplify it, just leave it like that. That's the smallest non-negative because it was the only non-negative. So this whole row right here becomes the pivot row. We call it PR, pivot row. And I'm going to highlight it in this blue color. So if you notice, they have an element in common, right? The element they have in common is your pivot element. Okay? So we're actually going to perform a pivot, but let's look at this. Do you see that the number I circled, this 11, was the intersection of the pivot row and pivot column? So now we're going to pivot. When we say pivot, that means make a unit column, which means the entry that we've circled needs to be a 1. And then everything else in that column, all other entries have to be zeros. Okay, so we want to make that entry into a 1. So how do you change an 11 into a 1? And think about your row operations when you practice your Gauss-Jordan process. If you've forgotten the process, to make 1s, we use row operation 2. A fast way to remember that is to do 1 over the number to change, or the reciprocal of the number you're trying to change, times the row you're trying to change, and put it back in the row you're trying to change. So we want that 11 to be a 1. So you have to think about it this way. We can also say we're dividing by 11, right? So we're going to do 1 over 11 times row 3, and we're putting it back in row 3. So row 3 was 7, 4, 11, 0, 0, 1, 0, and 30. So we're going to take 1 over 11 times row 3. In other words, we're dividing by 11. Do not simplify these. Leave these as fractions. You see this? This right here is going to be the new row 3. So there we have it here. I just retyped it. Look at this guy. 30 over 11. Wasn't that the same thing we got when we tried to find our pivot element? Wasn't that the smallest ratio? It's always going to be that way. So notice I have still circled this entry in the 3, 3 position. We're going to pivot, make that one a 1 and everything else zeros. So we're going to start making zeros here, here, and here. Let's do a process. So to make zeros, you've forgotten, an easy way to do it is once you have the 1, so we do the negative of the number we're trying to change times the row that has the leading 1 in it that conveniently lines up with that column. I've circled it for you. Plus the row we're trying to change, we're putting that back into the row to change. So this is the additive inverse. -3 plus what gives me 0? Well, we need the opposite here. -3 plus a +3. So we're taking the negative of the number we're trying to change. The negative of -3 is a +3 times the row of the leading 1 that we've conveniently circled for you right here, plus the row to change, row 1, and we're putting it back in row 1. So let's do our scratch. Row 3 is 7/11, 4/11, 1, 0, 0, 1/11, 0, and 30/11. So row 3, we get to multiply fractions. Remember, when you multiply fractions, if you have A over B, and you multiply the whole thing by 3, it's more convenient to write it as 3/1. You do top times top, bottom times bottom. So if I multiply every single one of these by 3, it's convenient to write it as 3/1 if I have a fraction. Okay, so I get 21/11, 12/11, 3, 0, 0, 3/11, 0, and 90/11. I'm going to add that to row 1. Just going to recopy row 1. 3, 4, -3, 1, 0, 0, 0, 23. It's your favorite thing ever. We get to add fractions. Okay, so we need to build common denominators, right? So I'm just going to recopy the row 3. So 21/11. And your calculator will do this too. But let's just practice in case you want to remember how to do this. So this 3 needs to be, this is like 3/1. I need an 11 on the bottom. So I need to multiply by 11 on the bottom, better multiply by 11 on top, right? So row 1 will be what, 33/11. The same thing here, multiply by 11 on top and 11 on bottom. So that turns into 44/11. This guy can be rewritten as -3 because there's no fraction there, same as this one. Okay, and this is a 0, this is a 0. And then 23, we're going to multiply by 11/11. Okay, and looks like that's what? 253? Okay, and then this gives us the new row 1. So, looks like that's what? 54/11. 56/11. That one zeroes out as it should. We get a 1 and get a 0. 3/11, a 0. And then what? 253 plus 90. We get what? 343/11. This is the new row 1. Okay. So let's check it. Is that what we get here? 54/11, 56/11, 0, 1, 0, 3/11, 0, and 343/11. Perfect. We're going to keep going. So notice I have still circled the pivot element because we do not have a unit column yet. We're going to change this entry and this entry both to zeros. So the negative of the number we're trying to change a -3, so we're going to multiply by a +3, times the row that has the leading 1 in it that we've conveniently circled for you, plus the row you're trying to change goes back to the row you're trying to change. Okay, so I'm going to multiply by 3/1. Okay, so we end up with row 3 is what? 21/11. Same thing as it was before, right? 12/11, 3, 0, 0, 3/11, 0, and 90/11. And add row 2 to that. Okay, but we really need common denominators. Okay. I think I wrote this wrong. This should be 12/11. Need a common denominator of 11. So we get a common denominator, multiply the top and bottom by 11. I'm not going to do it because it's kind of busy, but 5 times 11/11 gives us 55/11. Then we get -44/11. Leave this one alone, and this one alone, and this one alone. That one alone as well. Easy. 110/11. Okay. Then we combine these. So this gives us a new R2. we end up with what? 76 over 11, negative 32 over 11, 0, 0, 1, 3 over 11, 0, and I think it should be a 90. I copied that wrong. 200 over 11. Okay, let's check and see if we have the right thing. So this is the new row 2. Let's check it with our row 2, and then I've actually typed it out for you. So 76 over 11, negative 32 over 11. Got it, got it. 0, 0, 1, 3 over 11. 0, 0, 1, 3 over 11. 0, and then 200 over 11. Perfect. So we still don't have a unit column. Gotta keep going. So we still circle the pivot element. This needs to be a 0. So we're going to do the opposite of this, the additive inverse. So 2 times row 3 plus row 4 goes to row 4. Okay? And you can keep going. I'm just going to show you what the step would be. If you did this process, you would end up with this matrix here. And you see that this guy, the Z column, is now a unit column. Yay! Okay, so we say, well, has an optimal solution been reached? No, why not? An optimal solution has not been reached because there's still a negative down here in the bottom row. So we did successfully pivot on the 3, 3 entry, but we have to keep going. So let's select the next pivot. Pick the most negative entry here. Well, there's only one, so it has to be this. That's our pivot column. Then for a pivot row, we do our ratios, right? But we do the constant divided by the entry in our pivot column. So if you divide by a fraction, that's the same as multiplying by the reciprocal. So we end up with 343 over 56. And here we have 200 over 11 multiplied by the reciprocal. 11 over negative 32. We can stop right there because we're going to get a negative. 30 over 11 times 11 over 4. We get 30 over 4. Okay, and you can obviously reduce these. We're throwing this one out. This one is the smaller of the two. This is our pivot row. So this is the pivot entry. And we would keep going. Change this entry to a 1. So you would do the multiplicative reciprocal. So 11 over 56 times R1, and we're putting it back in R1. Okay, and if we do that process, multiply every single one of these by 11 over 56, we will end up with this. Now this 343 over 56 should look familiar. That's what we had when we did our pivot ratio, right? Okay. And we would keep going, right? We do row operations. We would change this to a 0 and this to a 0 and this to a 0. You getting tired yet? Is it okay if I just tell you the answer? So here's the final simplex tableau. How do you find the solution? Well, we know there's a solution because there's no more negatives down here. So how do you find the solution? Well, here's the steps right here. But what we're going to do is anything that's not a unit column, we're going to scratch it out. Not a unit column, not a unit column, not a unit column. And of the ones we scratched out, they're not unit columns, we're going to assign them a value of 0. So we assigned values of 0 to all the variables that didn't have unit columns. And then we're just going to pretend they're not there, right? So we look at, you have a 1, 0, again, pretend that's not there, 1, 0, 0, 0, and then a 49 over 8. So 1y plus 0z plus 0s2 plus 0p equals 49 over 8. Oh, wait, that's y equals 49 over 8. Okay, and then z, you see that z, there's a 1 in the z column down here, row 3. Again, 0, 0, 0, and a 1/2. So z is 1/2. S2, okay, there's a 1 in the row 2. We got 0, 0, 0, everything else. So 1 S2 equals 36. And P is 57 over 8.